This video is about the extended possibilities of volume simulation in Stampac Xpress. Using these 4 examples, we will take a look at the advantages of the simulation with volume elements over shell elements. The first example deals with the topic of surface quality and the prediction of markings and injuries in the surface. Here we see a photo of a sheet metal component on the right. The pronounced markings on the surface are also clearly visible in the simulation result on the left. In this animation we can see the cause of the defects. Due to the set angle there is space between punch and eye. A wrinkle or so-called bag can form. Only at the bottom dead center of the press, the gap between the dies is reduced to the nominal sheet thickness. The fold is pressed again, and the marks shown are created. The shell simulation, here on the left of the picture, cannot show this result in all clarity. We see another picture that clearly shows the processing traces of the tools. In this example we are dealing with the deliberate reduction of the material thickness. This is a copper component which is reduced from 0.4 mm to 0.2 mm. The component is fixed on the right side of the strip connection. In the animation we see how the strip grows in length and width. Here we see the process in section. On the right side, the material cannot flow due to our fixation. There are throw-up forms at the edge of the stamp. With this simulation the required force can be determined. The cutting can also be optimized. The shell simulation does not show the increase in length and width. The next example has a similar topic. Here it is about ironing. The round pot is tapered from 1 mm to 0.6 mm in wall thickness in the second draw. With this part the effect is intended. However, this process can also be unintended with other drawn parts happen when there are vertical walls and the part under the blank holder becomes thicker than the tool gap. Again, you can see that the shell simulation is not sufficient to accurately represent the process. In our last example, the bending radii are smaller than the sheet thickness. Whenever this is the case, we refer to a sheet as thick. Here again in top view and front view. Compared to reality, you can see how well the process is represented. The characteristic of the front sides and the throw up at the inner bending radius on the left are clearly visible. Finally, the comparison with the shell. Again, the shell simulation does not offer enough resolution to show all details. At the end we see once again the summary of the 4 examples. We hope that this video was interesting for you. And thank you for watching.